Okay, so in this lesson, we're going to learn how to write a compound inequality given a graph on the number line. So notice that you're given a graph here on the number line, and you want to write you want to write a compound inequality for this graph that's shown. So you want to use x for your variable. Okay, the way to think about this is to remember the difference between the dot and a open circle. So a closed circle or a solid dot or an open circle or a hollow dot. Sometimes they'll refer that way. So remember, a closed circle, a closed dot means that -4 is included, is a solution. An open circle means that in this case 6 is not included. Okay? And so the way you want to think about this is this. Let me go ahead and rewrite this over so I could draw on it. So here's -4, here's 6, closed circle, open circle. And so if we look at this part here, okay? So if I look at the way you want to think about this, if you look at this part right here, so from here to infinity, that means that x is greater than or equal to -4, right? So from here all the way to this way, right here, then that would mean that x is greater than or equal to -4. If you look at this part here, then that would mean going this way that x is less than 6. Y'all see that? So x is greater than -4, and then here x is less than 6. So I wrote this as two separate inequalities right here. Okay? Now another way to think about this is this. So notice that if I look at these two individual in the number line, just to show you another way, so here is x is greater than -4, and then on here's 6, open circle going this way. And so notice that what's shaded right here, this part here, is the intersection of those two. Now remember when we talked about intersection, we used the word and, right? We use the word and. So the way I can think of this right here is this. So you can think of this as being x is greater than or equal to -4, and at the same time, x has to be less than 6. And it kind of makes sense, right? So look, x is greater than -4, and at the same time, x has to be what? Less than 6. All right, but don't forget, that's the word and, though. So the intersection of those two. So notice these two graphs intersect at this part here. Okay? Now, another way to write this is this. So, and it's important you see this. So y'all agreed that all of the x's here will be any real number but that's between -4 and 6. So another way to write this right here is to say this. X is less than 6 and at the same time is greater than or equal to -4. So notice this right here. X is greater than -4 and at the same time is less than 6. All right, so make sure you, when you write it as this compound inequality like you see here, that the inequalities are pointing in the same direction. So x is less than 6, and this right here means that x also has to be greater than or equal to -4. Okay? All right. Now probably the answer they're going to want is this part here. So you'll say -4 is less than or equal to x, and it's less than 6. Okay? All right, so that's this one. So that's number 1. Let's look at another one. All right, so I want to write an inequality that represents the shaded region. So I'm going to think about it just like I did a while ago. So we're going to look at it this way. So here's 1, 7, closed circle, right? So that means both of those are included. And let me go ahead and shade it in. So this part here, right here, from here to infinity, means that x is greater than or equal to 1. So for x greater than or equal to 1. This part here means x is less than or equal to 7. So x is less than or equal to 7. All right? So notice, though, x is greater than or equal to 1 and x is less than or equal to 7. That's that intersection right here. So we're going to write it as x is greater than or equal to 1, and at the same time, x has to be less than or equal to 7. So x is greater than or equal to 1, and at the same time, x is less than 7. In terms of that single compound inequality without the word and, you're going to say all your solutions are between 1 and 7. So you're gonna write it like this. X is less than 7, and at the same time, X has to be bigger than 1. So that's how it looks. Okay? This is probably the way they're going to want the answer written as a compound inequality. I want you to always notice, though, those inequalities are pointing in the same direction, less than, less than. So this right here means that X is between 1 and 7. See that? X is between 1 and 7. The inequality symbol is easy to figure out. Notice X is less than 7, right? So anything here is less than 7, and anything here is greater than, see, X is, when you read it backwards, X is greater than 1, or 1 is less than X. Okay? All right, not difficult at all, right? Very simple process. Very simple process. Okay, so I want you to notice this one. So notice there are two separate intervals, right? Two separate graphs. So remember when you have those two separate graphs, that's that or statement. See that or statement? When you have just one graph like this, that's that and statement. When you have those two separate graphs, you're going to be looking at an or statement. Now, the way I want you to think, well, first of all, you got to remember this. An open circle means that this number is not included. A closed circle means that this number here is included. So -4 is not a solution. -1 is a solution. Okay? All right, now I want you to think about this. If I look at this in two separate graphs, so let's just think about this for a moment. So I have -4 open circle going to the left, and so this means, remember this means right here that X is less than -4, right? And then if I look at that other part of the graph right here, -1, closed circle, going to the right, remember that means X is greater than or equal to -1. And notice that these two graphs have nothing in common, right? So that's that or statement. So there's only one way to write your answer, and that is to use the or statement. So you're going to say X is less than -4, or X is greater or equal to -1. Now, you did not have to rewrite this over right here, but it does help to think about it like that. So whenever you have those two, whenever you have a graph where you have two separate intervals like this, you use that or statement. So X is less than -4 because of the open circle, so there's no equal sign, or X has to be greater than -1. So remember your solution, the solution here is whatever you see graphed here. Okay? All right, that's number 3. So remember, one single graph like this is an and statement. Looks like this. Two separate graphs like this is an or statement. It has to look like this. Okay? All right, so remember or statement. So this is an or statement here. All right, let's look at another one. All right, so number 4. Notice one graph, right? Not two like we had here, one. So that's that and statement. And so the way you want to think about this is in one of two ways. Let's draw each one individually. Well, actually, let me do it this way. So here's the open circle, closed circle. And so this part here means that X is greater than -6. And this part here means that X is less than or equal to 8, right? And then we look at the intersection. And so that's that and statement, So you're going to say this. You're going to say X is greater than -6, and at the same time, X has to be less than or equal to 8. But the way they're going to ask you to write this is not using the word and, but rewriting it where it looks like this right here. So it's very easy to see that all your solutions are going to be between -6 and 8. So -6 and 8, and the symbol will be, since there's a closed circle, we're going to say less than or equal to X, and then since that's an open circle, you're just going to use less than. Okay? And so that's the answer there. Very simple, right? Very simple process. Not difficult at all. All right, so let's look at number 5. So notice two graphs, right? Two graphs. So that's that or statement. Whenever you see something like this, think of that or statement. And then it's pretty easy to actually write this out. So your solutions will either be from here or here, right? So the solutions to this inequality, here's the graph. So it's going to be this or this. So you're going to say x is less than or equal to. Notice a closed circle. So closed circle means it's included. So x is less than or equal to -2, or, and then that's a closed circle as well. You're going to say x is greater than or equal to 4. And there's your answer. Not difficult at all, right? Very simple process. Very simple. All right, notice in this one, you have one graph. So that's that and statement, think and. When you have that one graph, think and. So when you think of that and statement, here's -3, 6. Notice they're both open circles. And this part here, when I look at from -3 to infinity, this is 6 right here. That means x is greater than -3. So there's no equal sign because they're both open circles. And over here, all of this would be x is less than 6. And then you're looking for that intersection. So hence the word and, right? And so you'll say x is greater than -3. And at the same time, x has to be less than 6. So x is greater than -3 and at the same time less than 6. As that compound statement, the way they're going to ask you to write this is to put x in the middle. So you're going to say x is less than 6, and at the same time, x has to be greater than -3. So -3 is less than x, and x is less than 6. All right, so that's the way they're going to want you to write this. All right, so I think you got the handle on this. So whenever you have one graph, you're going to think of the word and. Whenever you have two separate graphs like this, you're going to think of the word or. And when you have an and, though, you want to write it as that one compound inequality that looks like this. Rather than using the word and, they're probably going to want you to write it like this. Okay? All right, so that is the lesson on writing a compound inequality given a graph on the number line.